Okay, welcome. So section 8.3 is about hyperbolas. They're actually very similar to ellipses, at least not really, okay, not really, but kind of. They've got a similarity, or they're cousins of ellipses. So here what we have is we have two foci, okay, and the difference of the distance to the two foci is constant. Okay, so what this is going to end up looking like, let's take a typical example. Say I have, let's x squared minus y squared equals 1. Okay, and so what that's going to look like, and I'll explain how this comes out in a second, is we're going to have these two asymptotes, we call them. Let me erase that one here. Okay, now in this point, in this one, if I have x equals 1, I can have that, right? I can have x equals 1 or negative 1. But y equals 1 or negative 1 won't work, because if x is 0, notice that you're going to get negative y squared equals 1, which we can't do that without going into complex numbers. But if we have x equals, or y equals 0, we could have x equals plus or minus 1. So we're going to start here and here. And what it's going to look like is it's going to look like so. Okay, and so what we have is we're going to have a point here and a point here. These are where our foci are going to be. Okay, and we're going to take this distance minus that distance. So d2 minus d1 is constant. I don't want that in red. Let's put that. Okay. Now we're not going to actually have to really do so much with that. So let's give the actual sort of form of ellipses that we have. There's really two forms. Okay. Let me just check real quick. Yes. So we have two forms. We have x squared over a squared minus y squared over b squared equals 1. That's sort of like what we have here. Okay. So when we have x squared over a squared minus y squared over b squared, draw an axis here. Okay, and we're going to have something called a fundamental rectangle. Okay, so our fundamental rectangle is basically going to be a rectangle that's going to be left, right, A, and up, down, up length of B. Okay, so it's going to be like here. This is going to be A comma 0, negative A comma 0. And then up here, it's going to be 0 comma B, 0 comma negative B. And we're just going to draw a rectangle. Okay, and then we're going to draw the diagonals on that rectangle. Okay, so the diagonals on that rectangle, like so. No. And like so. Okay, and then we're going to do exactly like what we did for that first example. We're going to look and we're going to say, you know what? If y equals 0, then I'm going to get x equals plus or minus a. But here, x equals 0, I get something that doesn't make sense, at least within the real numbers. Okay, so my hyperbola is going to look like so. Okay, now we need to have a way to find our focus. Okay, so our foci, we're going to put them here. It's going to be on the same axis where it's oriented. Okay, this point's going to be c comma 0. This point's negative c comma 0. And now we're going to have a squared plus b squared equals c squared. And the way, again, I remember this, especially with thinking back towards the ellipse, is I think, you know what? My C has to be definitely bigger than my A. So the C is the one that's going to be on its own. Okay, remember when the ellipse, it was the other way around. The A had to be bigger, but now we're in hyperbolas. So the C has to be bigger. So it's, right, it's on the outside here. So A squared plus this B squared is going to give us this C squared. Okay, let's make that a little smaller, everything a little smaller. Just a little bit smaller. Okay, there we go. And we're going to do another one. We're going to do the other type is y squared over a squared minus x squared over b squared equals 1. Okay, so it's almost the exact same thing. Okay. Okay, again, we're going to have a fundamental rectangle. Ooh, that's bothering me that it's not straight. Okay, it's going to go left, right, this time B, and up, down A. We don't even need to worry about which one's bigger between A and B. Okay, we just need to worry about which one's the biggest, which is C. Okay, and let me draw my fundamental rectangle. See if it'll come through. Very ugly rectangle. Let's try again. Oh, that's about as good as I'm going to get. Draw the lines through the diagonals. That's a very bad one. Let's try that one again. Yeah, somewhat. Okay, not great, but oh well, it'll do. Okay, and now we're going to go ahead and say, okay, now where is my fundamental, or where does it start? Where am I starting the hyperbola from? And I realize, again, looking here, if x equals 0, then y equals plus or minus a will work. If y equals 0, this equation doesn't make sense. I can't solve that without going into complex numbers. Okay, so now I'm just going to draw my hyperbola like so. And I'm going to have my foci here and here at 0 comma c, 0 comma negative c, where a squared plus b squared equals c squared. Okay, so that's the basic form for hyperbolas. Let's go ahead and move this. Move this just a little bit out of the way. There you go. I think that's a little better. Erase this. Okay. All right. I'll see you in the next video where we'll start doing some problems. Oh, I forgot to stop.